ahead and move to this online format, okay? So I know this is not what you signed up for when you signed up for 2480 in winter 2020, but we are going to do the best that we can. And, I just want to remind everybody that we are, working this all out together, okay? So really, we only have 2 more weeks worth of content to get through, okay? So this week, we were going to discuss how to automate our spatial analysis. So remember last week we talked about all these different kinds of spatial analysis tools and functions that we can run: clip, buffer, intersection, spatial queries. Okay. And this week we're going to talk about how we can extend those and automate those across lots of data using what we call Model Builder and the Python programming language. Okay. Before we dig into that, yeah, hello. I hope that wherever this is reaching you, I hope that you are doing as well as can be expected. I've posted a lot of announcements on CourseLink over the past week or so, and so I just want to actually spell this out in person, so to speak, or just talk it out with you right now, okay? So where we currently stand, I am asking you to submit what you have for Lab 4 by the end of this week, okay? By this Friday, 5 p.m. to the CourseLink Dropbox that I've set up for Lab 4, okay? Which will be visible to, if it isn't already, it will be by Tuesday, okay? So I've laid out in detail on CourseLink, what we want you to provide us in terms of Lab 4 and how we're going to mark it. Bottom line is give us what you have, and you're going to get a passing grade out of it, okay? Really, the only reason why you would not get a passing grade is if you don't submit anything and you don't tell me what your circumstances are before that. So please do reach out if there are some circumstances, exceptional circumstances that are just keeping you from submitting anything. Okay, if you haven't had the chance to start Lab 4 yet, I know you no longer have access to ArcGIS. The good news is we don't care. You can do this lab more or less without ArcGIS. And we will accommodate that, no doubt, okay? Lab 5, now it will be posted shortly. It is going to be redone, and what I will be posting will be different than what previously was Lab 5. And this accounts for the fact that you no longer have ArcGIS available to you, okay? So instead we'll be doing some work around web mapping and Python programming that you can do without having access to this big old piece of software called ArcMap. Instead, you'll be working with ArcGIS Online, as well as some online Python tools. That lab will be due April 10th. Okay, so we're just pushing everything back a week, more or less. Now, as part of Lab 5, I'm part of the grading for that will be a set of questions that correspond to the lecture material, so the stuff I'm going over right now. So you will get credit for Lab 5 for just having gone through these lecture presentations and responding to some questions. At the end of each lecture, I'm going to have some questions. Those will be the very same questions I will be asking you to complete through the CourseLink quiz, and that we will grade as part of Lab 5. Okay, so it's all about incentivizing you, just trying to help you keep on a normal rhythm of as much as possible of going through lecture and keeping on up to date with the content. Finally, the final, as you've seen, I've switched it to a take-home exam. Okay, so I just, given the responses that you had around internet access and reliability, there's no point in just kind of recreating a final exam, but online. Instead, I'm going to give you the time and space to work through a set of questions on your own. Okay. So I will make that available to you on the 13th, and it'll be due a week and a half later. Okay. And I've spelled out a little bit about the format of what that will look like on CourseLink. Please go and just take a quick look at that. But I will tell you a lot more about the format as we move closer to that. And I should say that this is, that plan for the final is not set in stone. As you might expect, there's a lot of moving pieces in our world right now. So it's just to say that that's the current plan, and things may change between now and then. Okay. All in all, our goal in the remaining few weeks together in this course, flexibility and fairness. Okay. And so flexibility in terms of accommodating the circumstances that you find yourself in, and fairness in my response to those circumstances. So do not hesitate to reach out and just let me know what's going on in your life right now when you're able to, so that I can make the rest of this semester work for you. Okay. Again, I'm always available. Don't hesitate to reach out. Okay, maybe not always available, but I will respond as soon as possible, and you shouldn't feel at all intimidated or restricted from just reaching out. Okay. So let's talk about ArcGIS and more broadly how we automate spatial analysis. And this goes beyond ArcGIS. Okay. We can do spatial analysis, beyond just this one particular software. And in fact, that is what we will see a lot of in our demos, and what you will be doing in Lab 5, at least a little bit, okay? Now, this is where there's a lot of technical challenges that are going to come up throughout all of this, and learning Python and learning Model Builder within ArcGIS is technically challenging in and of itself. Doing so without the help of the computer labs, without in-person instruction, it's going to make it doubly difficult. Okay, so I realize that, and it's my job to make this as fun as possible. Okay, yes, I said fun. Hopefully, I will be able to convince you that Python programming can actually be fun. Okay, so it's all to say that I understand that we are finding ourselves in very challenging technical circumstances. Okay, and on that note, I just have to play this because this is one of my all-time favorite Simpsons quotes.
Press any key. Where's the any key? I see ESC, Catarl, and Pigup. There doesn't seem to be any key. All this computer hacking is making me thirsty. I think I'll order a tab. Oh, no time for that now. The computer's starting.
Whoop. Okay, so if you find yourself in a situation like Homer, where you're working from home, and you're running into some technical challenges, and maybe the point is that you shouldn't feel at all intimidated in reaching out to your TAs, to me, to the discussion board, to each other, and trying to work through this together. Okay, this is a drawing that one of you made last semester. Okay, just kind of illustrating the kinds of challenges that come up in learning Python. So you've got the students over here running away from Python back to the safety and comfort of Model Builder, okay, in automating spatial analysis. And I think there's really two important points to take away from this diagram as we begin to talk about Python and Model Builder and automating spatial analysis. One is that Model Builder is a kind of home, a safe place to actually explore and do spatial analysis, and to automate those tasks, to do clips and buffers across lots of your data. And so if you start to learn the Python versions or try to get into the more sort of detailed Python programming of spatial analysis and find yourself intimidated, we always have Model Builder, which is a graphical interface into spatial analysis, okay? So it's not at all a problem to be running away from Python back to the comfort of Model Builder. The other thing to note, though, is that actually, okay, so this Python has fangs, but, real Pythons don't really have fangs, or at least they don't, that's not how they get you, right? So, it's all to say that actually Python, while it might seem intimidating at first, the programming language might seem intimidating at first, it's all to say that, maybe it isn't actually as bad as you might think it will be, or at least at the very least, it's my job to make it not as bad as it could be. Okay, so let's just not get intimidated before we even dive into it. So we're going to start with Model Builder, okay, and let's walk through what we would want to do. Okay, so again, think back to last week or the last time we met. We were talking about some really important spatial analysis functions, such as clipping our data, creating buffers, doing spatial queries of our data, that sort of thing. Okay, and oftentimes, as we saw, we need to string together different spatial analysis functions. We might start by doing a buffer, and then we might create a spatial query, do a spatial query on that buffer layer, or we might create a buffer and then we'll do a clip of that buffer so that we extract only the information from the area encompassed by that buffer. Okay, so oftentimes when we do spatial analysis, we are stringing together different items and actions. And while we can do that by, sitting around and, waiting for ArcMap to finish, sometimes we want to be a bit more explicit and sort of draw out how to connect these items. And Model Builder is a way for us to connect together different spatial analysis functions, to string them together, okay? As we'll see in just a second. So I've provided you with a demo of what Model Builder looks like, and we are working with the Kawartha Lakes data, the tutorial data set. We've got our land cover there, our forest in that green. We've got our nesting sites, those are the points there on the right. And our goal is to create a layer showing only the nests that are within 50 meters of the forest edge. Okay, 50 meters on the inside of the forest, but that are on kind of the edge there. And so, I am not going to spend a whole lot of time going through this demo. It is there available to you. I've got the link here. The video itself is posted to the course link. I will just kind of walk through what this looks like and how we would put together this analysis in Model Builder. Okay, so again, this is a longer demo. I'm just going to kind of breeze through it. Okay, so we've got our data here. And under the geoprocessing menu, we're going to go to Model Builder, okay? And this opens up what we call the diagram. This is where we're going to actually sort of start to sketch out the different spatial analysis functions, specifically buffer and clip, that we want to put together. Because, we want these things to automatically happen together all at once instead of having to go to like buffer and then let it run and then do the clip. Okay, so first things first, we pulled in our data. We pulled in the roads. Okay, and we're going to add, or we could also add the data there, and we'll just string our, move ourselves along a little bit. Now we want to create a buffer around these roads. So we are going to search for our buffer tool, and we'll just drag it into this model diagram, or this model builder. Okay, and now we need to actually tell it that we want to buffer the roads. Okay, so we double click on the buffer, and it pulls up the buffer menu. Okay, this is just like the menu you would get if you went to geoprocessing and selected buffer. Okay, and we'll just input all the parameters or variables that we need there. Okay, and it connects them together such that we start with our input roads, these dark lines here. We buffer it, and we're going to get an output. Now, we also want to clip that data. Okay, now again, we could do this just sort of by hand, run the buffer and then take that output and then run it through a clip. But we want that all to happen at once. Okay, so what we're going to do is we're going to connect that output buffer from the roads, and we're going to clip it, or clip our nesting sites to it. So we're trying to figure out, what are the nesting sites within a certain distance of the roads. I know I said forests earlier. Turns out we're working with roads, but it's the same principle. Which nesting sites are going to be within a certain distance of those roads? So now together, we put together these two analyses, this buffer and this clip. We're going to tell it to put that output, that final output, those nesting sites that are only 50 meters within the roads, to the display when we're done. We're going to validate the model, which just means we're going to make sure that, we're going to test it and just make sure, that it actually will run. We're not going to actually run it. We're just going to test to see whether it will run, whether everything is sound. And we do that, and then we run it. And we get something that looks like this, and we change some of the symbols and whatnot, so that now we've done that whole thing all in one step, all in one model. We've buffered the roads and we've clipped nesting sites to within that buffer, 50 meters from the roads. So these squares here then are the nesting sites that are within 50 meters of the roads in Kawartha Lakes. Now what's really cool about this model builder program, or part of ArcMap, so we can then export our analysis so that we can load it again and even run it. So we go to Model and click Save As, and then, if we ever want to run this again, instead of having to go by hand and go geoprocessing, buffer, get the output, geoprocessing, clip, we can just load the model, quick run, and we've done the whole thing over again. Okay. So I know the demo here was about a road, but it's the same idea. Replace this with road, and that was what the demo was. Same thing with we could do with the forest, is we could buffer the forest, use that as the input, or as I should say the cookie cutter for a clip, pull out the nesting sites that only fall within that cookie cutter, and then that is our output. The nests are within 0 to 50 meters of the edge of the forest. Okay, so what we've done with the model builder is put these things together all in one kind of process. Now you might be thinking, it's not that bad to just run a buffer, get the output, and then go through and then run the clip. Problem is, when things get a bit more complicated, okay, so in the real world, not saying that this is in the real world, but in a professional setting, we often have data and tasks that we need to do that look something like this, okay, where we have many different spatial analysis operations that we need to do, and doing them by hand, clicking clip, clipping buffer, clicking, whatever, would take too much time and give somebody a hand cramp, really. Okay, so what we can do, what a model builder allows us to do is to string all those together so that we can just click run and ArcMap will take care of it for us. It'll run these things automatically for us so that we don't have to wait there for the next step to happen. So this is actually a real world example from the city of Salt Lake in the US state of Utah, where they are just trying to figure out, they've got some, it's their process of incorporating new data that they have on uh, counts of cars in certain streets on the city. You know, those little like wires that you drive across, and it counts like how many cars are going across the road. Well, this automatically takes that data, you know, geocodes it, you know, gets the location, the coordinates for where that wire was, and then it, you know, processes it and creates new shapefile so that every time we get new data from this survey of cars on the road, it automatically does all of this for us instead of us having to sit and each time go through by hand and do all of this. We can just click run. Okay, so that is an example where a model can be really helpful when we have new data coming in, but we need to do the same kind of processing and analysis of it. Build a model. Let the model do the work instead of having to sit there and do all this by hand. What is a model anyway? Okay, we went through the demo, we're stepping back a little bit. What is a model? So, you know, really a kind of simple definition here is a generalized representation of a process or object. Okay, a map is a model, actually. It is a model of the real world. It is not the real world itself, but it is a usually very generalized and simplified representation of the world. Okay, and that is essentially what we are doing when we create a model in Model Builder. Is we are, you know, sketching out our spatial analysis workflow. It allows us to see the whole picture. Okay, models in general allow us to see the whole picture, right? So I can see the whole world on a map. Okay, it allows us to see how component parts are related. Okay, we get to draw these arrows between things on models, especially conceptual kinds of models. Models help us share our understanding to others. I can, you know, create a model of something about how these different, you know, parts of the world fit together, and I can share that with somebody. And, you know, it helps us make sense of new data. So that's models in general, okay? But in Model Builder in particular, again, we are sequencing together spatial analysis and creating workflows, okay? Why Model Builder? Again, sometimes our spatial analysis takes hours and days. Now, none of the kinds of things that you've done to date in this course would take hours or days. But as we get into more advanced kinds of GIS, absolutely some of the things we're doing, either because of the volume of data we have or because of the complexity of analysis we need to do, like a lot of that can mean tasks, just ArcMap sitting and running for hours, or yes, even days, okay? And so I don't want to be, you know, at the computer lab in the Hut building in the middle of the night when the clip finishes so that I can, you know, be there to click to run the next step, the buffer, okay? I want that to all happen automatically, okay? And so this is a real advantage to something like Model Builder where we're stringing together our different tasks. It's also good for reproducibility. That is, if I can create a very general model that, you know, puts together input data, buffers it, uses that output as the cookie cutter for a clip, and then I don't really have to. I can just load any kind of data into that model. I don't have to recreate or reproduce my workflow every time. I can just use that model. It allows me to share with my colleagues exactly what I did. I don't have to think back, oh yeah, what did I click on when I was working in GIS? What was that button? Or how did I do this? Did I do this thing first or did I do that thing? No, with Model Builder, it's all sketched out there. And represents graphically what you did. And indeed, that's a key component here, is that it gives you a graphical interface to doing spatial analysis. Okay, it lets you sketch out the different input data that you're going to have, the spatial analysis tools that you're going to use, and the output you're going to have. And, as the little picture I showed you at the beginning that the lecture kind of pointed out, it can be a lot easier than using Python programming. Though we'll talk about some reasons why you might use one or the other. Key thing to note is that you need to. This is an extension in ArcMap, and you just need to authorize that extension. I don't know why it's not automatically authorized, but pay attention to this when you actually get a chance to use Model Builder in ArcMap. Just some terminology here. So we call this the canvas, and that is where we build our diagram. So something like this down here is the diagram, and we build it in the canvas. Okay. We have different elements, okay, to our model. So we have the tools, the things like buffer, has a little tool label here, or clip. Those are tools. Those are our spatial analysis functions. We also have variables. That's like our input and output data. So forest here would be our input data. That is a variable. And we also have connectors. These are those arrows that string together our data, our input data, and our spatial analysis tools like buffer and clip, and the output. Okay. And as part of that, we can have intermediate output data, stuff that we produce, as a result of our model, but that doesn't actually end up. It's not actually what we want. It doesn't end up in the final map. So, like when we did that buffer of the road, or of the forest, that was intermediate data that we only wanted because we wanted to use it as a cookie cutter to clip our data. What we were really interested in was the ultimate output, which was the clip of nesting sites produced using that data. So the result of the buffer, we don't actually output that. It's really the nesting site clip that we output, okay? Validation, this again, just make sure that our model is sound, that there's no errors when we run it. And that's an important thing to do as part of building any models, just to make sure that all the pieces fit together. And parameters, these are the things that usually as part of the tool, like the buffer clip that you just need to set, like how big is the buffer going to be? That would be a parameter. So I mentioned validation. Why do we do it? We have to make sure everything runs right. You have to do this for every time you should run a model. You should validate it. Otherwise, you'll run into errors like this. Okay. Now, some troubleshooting. This is going to be a key thing that we come back to again and again. But we're going to learn tips for troubleshooting when our technical, when we go wrong on the technical side of things. Okay, so you can try to isolate components, run them outside the model, just to make sure that your clip or your buffer would work, using the normal technique for creating a buffer. Sometimes as troubleshooting, you can try to export those intermediate layers that I talked about, like the buffer of the forest, just to make sure that those are right and are what they should be. I always, add the final results to your display using the Add Display to Display option. Okay, this allows you to just make sure that your output is what you think it is. When you click Run for Model Builder, you're going to see something that looks like this. It will tell you what's going wrong. It will give you an error code if there is an error, and it'll give you a bit more detail. Okay, this goes for any geoprocessing or spatial analysis tool like Clip or Buffer, not just Model Builder. Okay, always look at that model window. Okay. As an insight or a way into troubleshooting. And of course, you can also rename your elements. So instead of just calling something a clip, you can be a bit more specific about what is being clipped. Just to help you keep track, if you have multiple clips that you need to do in a model, it can help you keep track of what exactly you are clipping at that stage. So that just changes, this from clip, or in this case buffer, to something a bit more descriptive like forest buffer. And hopefully, fingers crossed, when you run a model, you get something like this, okay? Where it runs, it completes, and it succeeds, okay? And in an amount of time that is way faster than what you could do by hand. 3.84 seconds to create a buffer and to clip it. I guarantee you can't, move your mouse and click as fast as that, in ArcMap. Okay. I mentioned that you can export and save your model so that you can use it again. There's a couple ways to do this. You can. I'm not going to go into details here because we aren't actually going to end up working with Model Builder this semester. But for your reference, you can save it, just as you, as part of what we call toolbox. Okay, just park that. You don't need to memorize that, but that is a possibility. Perhaps more relevant, you can export it as a graphic so that you can share it with your colleagues and say, hey, this is the steps I took to get to the results I got. And you can also export it as Python, okay? So one thing we're gonna learn and that we're gonna keep coming back to is ArcMap is just a bunch of Python scripts, okay? When you click buffer, what you're doing is telling ArcMap to run the buffer script in Python, okay? And so when we create a model in Model Builder, really we are just creating a long Python script that consists of, the buffer code and the clip code and whatever else kind of code that is in part of our model. Okay, so you can actually export that from the graphical interface of Model Builder to the code in the Python programming language, and that can be helpful if you want to get more into the weeds of your script and maybe adjust some of the parameters. For sharing with other people, there are lots of reasons why you might want to export it to Python, including, as we'll see, if you want to run it outside of ArcMap. Okay, so we're going to see how you can actually do GIS without even opening ArcMap. Okay, but that will be coming up later. Some advanced techniques in model building. Okay, sometimes we want to run across multiple parts of our data. Okay, and to do that, we can use what are called iterators. So an iterator is something that helps us move through our data. So in the previous examples, we just had one layer of forests or roads that we needed to clip. But what if we wanted to clip multiple cities? We have a layer of consisting of 100 different cities in the province of Ontario, and we want to clip our land use raster to each of those cities. How are we going to do that? Well, we can use the iterate feature in Model Builder to clip that. Okay, so in this example, so we actually already are only looking at a few of the cities around Guelph. So let's say we have a dozen cities in the greater Guelph area, dozen municipalities. And each one of those is a row in the attribute table in our layer. So we've got a layer called Greater Guelph, consists of a dozen different shapes. Those are the boundaries of each municipality in the Guelph area. And what we're doing is iterating. We're going through each of those shapes, each of those rows in our attribute table, and we're just selecting that shape. We are using it as the cookie cutter for a clip. We are clipping the land use raster we have just, or layer we have, just to that. Okay, and the output is a file for each city called LU, and then the just a municipal ID for that city. Okay, and so at the end of the day, what we get is like a dozen or so different rasters, one for each of the cities we have in the Greater Guelph area. That is the land use just for that city. Okay, because we've clipped out just for that city the land use. And we've done that by iterating through this layer that consists of multiple shapes, each one a municipality in the area, okay? So instead of having to go through by hand and clicking, select Waterloo, clip land use to Waterloo, done. Select Kitchener, clip land use to Kitchener, done. Instead of having to do that by hand and taking maybe an hour to do that for a dozen different cities, we build this model, tell ArcMap to iterate through all those cities and that we have, Kitchener, Waterloo, Guelph, whatever, and we run it, and in the process of maybe a minute, it'll do all that work. Okay, so we're going from maybe an hour to maybe a minute. Another kind of iterator that we have is something called the for loop, okay? And this iterates across in this case, a set of numbers we have to create a buffer around each robbery, okay? So we say for each value that we have between 50 and 150, in increments of 50, so 50, 100, 150. Use that as a buffer around that robberies layer that we have for Toronto. So what this is going to do is going to start with 50, and it's going to create a buffer of 50 meters around each robbery, and output that as a shapefile. And then it's going to go to 100, and it's going to use that 100 meters, and it's going to use that as a buffer around each of our robberies, and output that. And then it's going to do 150, and output that as a shapefile. Okay, so that is another kind of iterator we have, iterating through a list of numbers that we have, and doing a spatial analysis technique, in this case, buffer, based on that value. This gets us into a discussion of Python, because these iterators are something that, are actually, not, again, it's advanced model building. It's not necessarily easy to do or implement in Model Builder, but where it is easy to work with and do is in Python, the programming language called Python. Okay, so we're going to start to talk now about how we use this programming language to manipulate and access and report on our geospatial data. And we're going to talk about that in the context of ArcGIS, even though you will not be using Python in ArcGIS. It's important context, and you will use Python in ArcGIS in later courses. But we will also be talking about just generally how we can use Python, the programming language, to manipulate and retrieve data, okay? So let's say we had a similar goal in mind. We want to put some buffers around each of these robberies in Toronto. And in this case, let's say we have 4 buffers we want to make, 50, 100, 150, and 200. Okay, now we could do that with a multiple ring buffer. We could do that using this iterator approach in Model Builder. But we could also do it very easily using the Python programming language. So let's see what that would look like. Now there are 2 ways we could do this in Python. And I'm going to show you this, and we'll eventually get to the point where this will actually make more sense to you. But let's just see what this would look like. In this first example, this part up here, we have a list of different distances, 50, 150, 200, 250, so on and so forth. And we say for each distance in that list of distances, if the distance is less than 250, that is if it's 50, 100, 150, or 200, do a buffer of our robberies at that distance, okay? And using these parameters, we want to dissolve the buffer, right? Remember, this is all this right here. This is just the Python way of opening the buffer menu. Okay, so this little nugget right here, arcpy.buffer _ analysis, all that is when we go to geoprocessing in the ArcMap, going to the geoprocessing menu in ArcMap, and we click on buffer, and it gives us all these drop-down menus. That's exactly what this is. We choose robberies as our input. Remember, that's the thing that we want to create the buffers around. We tell it what the output is, and in this case, we're going to create a shapefile called robberies, underscore whatever the distance is, 50, 100, 150, so on. The distance we want the buffer to be is just, as we loop or iterate through this list of distances, it's going to be 50, and then it's going to be 100, and then it's going to be 150, 200. And these are all the options that we have in that drop-down menu, in that normal buffer drop-down menu, including the option to dissolve all the buffers so that they look dissolved like this, as opposed to each one just kind of overlapping one another. Now, this will accomplish the same thing, this down here. This is a different iterator, while. It's a different iterator. So we start with our distance being equal to 50, and we just say while the distance is less than 250, do the buffer, same exact code as above. So the first time it goes through this, it will say, well, okay, distance is equal to 50, and that's less than 250, so I'm going to do this. I'm going to do arcpy.buffer, create a buffer of 50 meters around the robberies, and then we're going to increase the distance by 50. So we take 50, we add another 50, and we get 100, and we go back, and we say, well, distance less than 250, which is true. It's now 100, which is less than 250. Do the buffer, and we increase it by 50 again. So we're now at 150, and that is also less than 250. So we do the buffer again, we increase it by 50. Now we're at 200, we go back. Still less than 250. All right, well, we do the buffer at 200 meters. And it outputs that, and then we increase it to this 250, and we come back again. But this time, the distance, which again is now 250, is not less than 250. And so we stop. And we get, the 4 buffers we want. The 4 buffers at 50, 100, 150, and 200. Okay. So that is one example, and again, I know it doesn't make sense yet, but we're going to dig into exactly how this works in some more detail. Let me give you some context first, though. Where we're going to go is we're going to talk a little bit about why GIS programming is important, introduce more about this programming language, Python, how to code with it. I'm going to do a demo of coding with it that will be very helpful to you in Lab 5, that assignment. We're going to talk about how to do it in ArcGIS. Now, I know you don't have ArcGIS at hand right now, or most of you do not, so, this is really going to be, for your own benefit, looking forward to future courses where you will be working with Python in ArcGIS. Share some examples from that and then provide you some further resources. So when we talk, so just to illustrate very basically, when we talk about, the intersection of ArcGIS and Python, we're talking about this particular thing called ArcPy. Okay, so we'll come back to that. Just to say that there's a whole world of Python out there that has nothing, this is a programming language, as we'll see, that is, used in everything, all parts of our computing world, not just ArcGIS and not just GIS software. Okay. So, why GIS programming? Okay, the problem is that, there's, again, ArcMap, all it is actually just Python, okay? Behind the scenes of everything you're doing in ArcMap is a bunch of code written in Python, that programming language that executes or tells your computer to execute certain things, okay? So when you click on the buffer function in ArcMap, it is really what it's just doing. And when you run a buffer function in ArcMap, it is really just running a Python script that tells your computer to, or relies on your computer to run that Python script, okay? And so that's all just to say that ArcGIS is a kind of it is a compilation of all this different Python code. It is not just a compilation of buttons you can push, okay? Because it is there are ways that you can access functionality in ArcMap that go beyond the buttons that are there, because you can because it is at its core Python code, okay? So if you view ArcMap or any GIS, it's just what you can click on, what buttons are available to you, you're going to be quite limited, because there is no button for how to run a buffer and then a clip. Those buttons exist separately, but there is no button that is sort of buffer clip. You can create that, though, when you write a Python script to do together a buffer and a clip, okay? And so, when a button like a buffer and a clip doesn't exist, you could wait around for years waiting for somebody to add that, or you could write the script and the code yourself. This is going to help you, move through your workflow much more quickly. Now, maybe a better reason why you might want to learn GIS programming is because you would like a job. Most job postings in the field of geomatics are going to be looking for people, be recruiting people who have GIS programming skills, okay? Because it is a way to automate workflows and make them much more efficient and reproducible. Employers want you to be able to do GIS programming. Here's one that I pulled up last fall, okay? Just kind of to me 5 minutes just to pull up, a job posting for a basic kind of intro GIS analyst. This one actually happens to be working with Esri or Esri Canada. Okay, and you don't have to look very hard. They clearly want somebody who has programming skills. So yeah, let's look at what they want. They want proven experience with ArcGIS for desktop. That's you. You have that. You are so you're on that path. They want somebody who can deliver GIS-based solutions, right? That's what you're learning in 2480. That's what you'll learn in 3480 and 4480. But they also want somebody who has experience with process automation, either in Model Builder or with Python. Okay. So that's what they're looking for. And this other one here, they want somebody with geodatabase design and implementation experience. We're not learning geodatabases in this course, but it is something that you will be able to learn in 3440, which we will begin offering next semester. So just a little plug there. But again, really key here, experience using some of the following, including Python, experience with process automation, potentially Python, okay? The reason they want these skills is because again, it can really help automate and make more reproducible your spatial analysis workflow. Now, ArcMap is not the only GIS software out there. It is the industry standard. Others, including the open source QGIS, exist, but even they will have support for interacting with the software, okay, using programming, and in particular Python programming. Okay. Okay. So this is not only ArcMap. Let me say a little bit more about why Python programming is so valuable. Okay. Task automation. It's going to save you time, reduce labor, and reduce your errors. Okay. So instead of having to spend an hour clipping land use to each municipality in Ontario, you can build a Python program that does it automatically. It'll do it much more quickly, and you don't have to sit there and wait for each clip to finish. It'll go through each one. Okay. Now that is just one kind of GIS operation. You might have a clip and then a buffer and then another clip and then an intersection and then a spatial query or whatever. If you have multiple things that you need to do in a row, that can also be a great opportunity to automate. If you have hundreds of different municipalities or hundreds of files you need to work with, and you're doing the same thing over and over again, you're doing a clip over and over again, automate that. If you're going to have to do this in the future, because next year they're coming out with new land use data, 2020 land use or land cover data, build a model. And when that new data comes out, all you have to do is change the input data from 2010 land cover data to 2020. And poof, there you go. You just change the input data. The whole rest of the process is the same. The clip for each municipality is the same. That part of the model is the same. Just the data is different. But if you have the program or the model in place, then you'll be set. And again, if you need to tell somebody like what you were thinking, what you were doing when you were putting this all together, if somebody wants to look and sort of check in on your work, a program, a script, is evidence of that work. In this course, you've just been, sitting at, in the hut labs, doing your analysis, and we haven't asked you to actually tell us or show us how you got to the results you did. But in a professional setting, your boss might want that evidence because they want to make sure that you did things properly, so on and so forth. In a Python, in a script, can actually evidence that. Just a really quick example, of what task automation looks like. So we might have, a bunch of files in a folder, and these are .xyz files. It just means they have 3 coordinates, so a lat, a long, and a height or elevation coordinate. And we might need to convert that to a shape file. Okay, so instead of doing that by hand, we would write a script that does that automatically, takes those comma separated data and creates shape files out of them. Once we have those shape files, the next step in the series of spatial analysis or geoprocessing that we would need to do, that we want to do in this example, is buffer them. Okay, so instead of waiting for a script to finish, converting the shapefiles, or waiting for ArcMap to do it, or doing it by hand, a script, we could just write it automatically. The next step is buffer. And then the next step is select all the points. Do a spatial query that fall within that buffer. Okay. Again, these things we can write in a script to happen automatically one after another, including the next step being interpolate, which is a kind of spatial analysis technique that you will learn in 3480. Okay. Interpolation can take a lot of time, hours. Okay, you don't want to be sitting there waiting for it to finish. You want it to automatically go to the next step when it does finish. Okay, let it run overnight, and go home and have fun. And maybe that last step is clipping it. Again, there is no button in ArcMap to do all this. There is no, how to convert a LiDAR file on elevation or height data to a raster digital elevation model. There is no button for that. The individual tools, the intermediate steps, are all in ArcMap. The buffer, the clip, the select, the spatial query, the interpolation. Those are all tools within ArcMap. And it's our job to string them together in a script to make that possible. Okay. So again, if you only think of ArcMap as a series of buttons that you can click, or that it is limited to the kinds of things that you can click, you're going to miss out on a lot of what we actually need to do in geospatial analysis, like these kinds of tasks that involve a series of individual spatial analysis functions. And so what this is getting at is sometimes we need to add new functionality to existing GIS software. Now, this is a little bit complicated and advanced beyond what even we will do with GIS, or with Python and GIS. So I'm actually going to skip over this. It's all to say that, especially with our open source GIS tools like QGIS, we can extend them by creating what are called plugins, or even libraries that help other users access some of the kind of hidden behind the scenes functionality that our GIS software enables. You might even build your own GIS software. Again, not something we're going to do in 2480, but this is something that in a professional setting, you might find yourself doing someday with the help of programming, be it in the Python language or even some other language that you might end up learning. Okay. Good news is that you already have some scripting experience already. Okay. So what do we mean by that? Where have we seen this? So when we did a select by attributes when we use that menu and that tool, when we did attribute queries, we were actually using what's called the structured query language, or SQL. Okay, this little bit right here, select asterisk from Canada where name equals Ontario, that is actually a programming language or a query language called SQL. Okay, and you use that language to instruct the computer to select the province from Canada where the name was Ontario. You didn't actually do that, but when you selected the counties from New Mexico where the share of renters was over a certain percentage, you were using a programming language to instruct the computer to do something. When you use the field calculator to convert the raw number of farmers using GIS or GPS in a county across all census divisions in Canada, convert that to a rate, a percent of farmers using GPS in those census divisions, you're using either the Visual Basic scripting language or even Python. Okay, so when you open the field calculator, you have the option of using either the Visual Basic language or the Python. So this is actually a programming language right here, and you've done it. You've scripted, you've instructed the computer using a script like this to do something before. Okay, so this is not out of the realm of, out of nowhere or anything. You've been doing this kind of work already. I'm going to very quickly go through some of the history of how we've automated spatial analysis in ArcGIS before, and use the Python programming language as part of that, just to give you a bit more context. Okay, so in the early days, even before my time, frankly, we had what was called the ArcInfo workstation. Okay, and it was just essentially this command line tool right here that you see in the image. So you didn't actually get any visual indication of your data. There was no graphical interface to the data. Instead, Arc was just all this text stuff here that told you what projection you're using, and what are the boundaries of the data and all that. So everything was done by programming, actually. It wasn't until we got what was called ArcView that included this thing called ArcPlot, where we could actually start to view the data. And that eventually, became a bit more sophisticated. Now, in ArcGIS 8, okay, this is actually where ArcMap, as we know it today, was introduced. Thing is, they took away all this command line programming by hand stuff in ArcMap or ArcGIS 8 and switched it out. And that made it a lot more difficult for people, okay? Because then they all of a sudden couldn't access some of the really core functionality of ArcGIS. And so in ArcGIS 9, they brought that back, and they brought it back using Python, okay? Such that today in ArcGIS 10, and we're using 10.5 and 10.6 in the labs, we are still working with the Python programming language. So what is Python, and why are we using it? Why is it in ArcGIS? Well, it's easier than other programming languages to learn. Okay, it's fairly readable of a programming language, and it's not just a GIS. It's not just for GIS. Okay, this is you can, if you look at any major application out there in the world today, there's probably some component of it that involves Python, whether it's Facebook or Gmail for that matter. There's somewhere in there that involves Python programming. Okay, it's not necessarily all Python, but Python is everywhere in our digital world. Okay, not just GIS, but that means that we can integrate what we're doing with Python and GIS with other applications. Okay, it's freely distributed, unlike ArcMap, and there are a bunch of people using it. So there's lots of online help and tutorials, including the site Stack Overflow, which is going to be very helpful in helping us debug some troubles that we run into when we start to learn and use Python. Some drawbacks here that are kind of technical that we don't need to, that you won't be quizzed on or anything, okay, just there for your information. It runs a little bit slower than maybe other programming languages, and it maybe isn't as powerful as other programming languages in terms of building an entire application. But that's not something we really need to worry about at this point. So let's see what this looks like, okay? Coding with Python, the basics. Let's start with this example. And it looks like something we'd be working with in GIS. It looks like an attribute table where we've got our ID, some fields that have different attribute values associated with them. You could imagine this corresponds to a shape in a shapefile where we've got the shape of the country of Italy out there. And this is just, some detail about that. So how would we represent that in Python? Well, there's some terminology here that's important. Literal, the actual value that you are working with. A variable represents a literal. So let's look at an example. If I create the variable CNTRY, I would set that equal to Italy, or I could set that equal to Italy. Italy is the literal, it's the actual value. Country is the variable. Another example, population. That's the variable. 61 million is the literal. This equal signs, it means, that's how we assign values or literals on the right to the variable on the left, okay? So when we're writing out a Python script, we say, variable equals literal, country equals Italy, set country equal to Italy, okay? An important thing to note here is that Italy is in quotation marks. It is a string. Okay, that is the format. Think back to the different kinds of formats of data we can have in ArcMap from week 4 or 5, excuse me. Whereas this here is an integer. So population is not a string, it is an integer. Which is just, 61,321,000. Lists, another super important fundamental data type. Lists store sequences of items. We use them using square brackets, and each item in a list is separated by a comma. So an example. The variable attribute list is equal to, here we have the bracket, the integer 1, which, just taking this example, Italy, a string Italy, and then the two other attributes, 61 million and the square kilometer, the area, 300,000, another integer, okay? Each one of these is separated by a comma, okay? Important to note that items are 0 indexed. So this is position 0, 1, 2, 3. 0, 1, 2, 3. So if I want to access Italy, I would write out the syntax here would look like this, because Italy is in the first position, 0, 1, 2, 3. I would use this. I would write out the variable, put these little brackets in, and put 1 to access the first position of this list. And the result, what Python would return to me, would be Italy. Okay. Final important data type, what we call dictionaries. Dictionaries store pairs of keys and values. So let's see what that looks like. Here's an example. I have a variable called cities, and it is equal to, note this, curly brackets, okay? And it consists of two key value pairs. The first key is name, okay? And it is in quotation marks. And then a colon indicates that it has a pair, that the value of this key is Guelph as a string. Okay, this is the kind of like, the value. Likewise, I have another, and then I separate it by a comma. So very similar to a list, but instead I'm actually able to, kind of give some of the, a bit more information here. So the second key value pair I have is pop, population, colon, setting it equal to 150,000. Okay. When this is an integer, right? So again, name in this example, in this dictionary created by these curly brackets, name and pop are the keys, Guelph and 150,000 are the corresponding values. Now to access those values, we use the keys. So I have cities. I use the square brackets again, because those are what I use to access data in the cities variable. And but instead of using an integer, I use the key. So I'm unlocking the value of the name of the city using the key Guelph. So when I do this, when I write out this, Python will return to me Guelph. Now, we can use lists and dictionaries together to store our data and to make it efficient to retrieve them. Okay, so I might have cities in Ontario stored like this. I might have a list of 3 different dictionaries, each representing a city in Ontario. This first dictionary, again, curly brackets, is Guelph, comma, the next dictionary, next curly brackets, Toronto, and comma, the next curly brackets, everything in there is Ottawa. So within each dictionary, I have a bunch of information about that city, including the name, the population, and coordinates stored as a list. Okay, so I can nest lists in a dictionary within a bigger list. So how would we access all this information here? Well, I would write out the variable name, cities. If I wanted to get Guelph, remember Guelph is in the 0 position. It is a dictionary in the 0 position here. It's the first one there, which means it's in the 0 position because it's 0 indexed. So if I did city 0 and then name, because I want to access the name here, Python will return Guelph. If I want to get Toronto, and I wanted to get its coordinates in particular, I would do 1 because it's in the first position, the first index position, and I would do chords, which would return the list of coordinates. If I wanted to get the latitude out of that list, I would just add on the 0 here to pull out this specifically. So I can nest these different retrieval methods together or combine them together. Get the first, get the index position 1 data, get the coordinates of that, and get specifically the first one here, which is the latitude. Now, usually I should note that we store longitude first. That's just the standard. For whatever reason, I've put latitude first. It's a confusing standard to store longitude first because usually we say lat long, but the standard is actually to store longitude first. And likewise, if I wanted to get the population of Ottawa, well, it's in the second position here. So I would do, or sorry, it's in the third position, which means it's at the 2, right? 0, 1, 2. And then I would just access the pop key to get its population. A little bit more about how we write out Python script. Okay, this is actually right here is a very simple script. We set our input variable equal to a string representing the pathway to our data. Okay, so we have some data in the data folder. It is the road shape file, and we specify the pathway to it. We specify a distance, in this case 50, and that will be 50 meters in our projection system by default. If we're working with a projection system that is meters by default. And we store both of those pieces of information in a list where input goes first. We just plug that variable into here, and distance goes in. So variables can act as substitutes for raw values. Instead of having to just include 50 here and include the pathway in here, we can just use a variable such that we do, when we call the buffer function, arcpy.bufferAnalysis, all we have to do is include the input, include the output name that we want, and the distance. So it's going to pull in the input from that part of our computer, that part of our C drive on our computer. It's going to output it as this, and the buffer is going to be 50-meter buffer. Now there's some technical details around here with slashes that I'll read over that are not going to be important to you for Lab 5 or anything like that, but that are important for how we specify pathways using the Python programming language. Now we can store and access our data, in the ways that I've just described using the Python programming language. But we also often want to actually query our data using logical tests. Remember when we talked about spatial analysis last week? We talked about relational queries. Okay. This is the same sort of thing, but written out using a programming language. Okay. So we have logic operators, and some of the really important ones include things like testing for equality. Does the literal of this variable equal the literal of some other variable? We use the double equal sign to do that. Greater than, less than, not equal to, as well as what we call if-else and else-if statements. So let's look at this script down here. We have a city. If we have a variable, called Guelph, a variable called city that is set equal to Guelph, well, we could write a script that tests what our city is. If the city is equal to Toronto, then print the city is Toronto. Else, if the city is equal to Hamilton, print the city is Hamilton. Else, print the city is neither Toronto or Hamilton. So what do you think is going to be the result of running this script? Okay, we throw this into our computer, or we plug this into our Python compiler, and we hit run. What is the computer going to spit back at us? It's going to say this city is neither Toronto or Hamilton because the city variable has been set equal to Guelph. We test if it's equal to Toronto, which is going to prove false. So then we move on to here. We test if it's equal to Hamilton, which is going to prove false. Then we go down here, and all else has failed. All else is false. So we say, well, the city is neither Toronto or Hamilton. Iterators. So going back to our discussion of Model Builder, we can do the same exact thing, iterating over our data in Python. In fact, it is much easier to do in the Python programming language. So we have while loops and for loops. So let's start with our while loops. We saw this when we created that buffer. So we start with a variable x equals x, and it's equal to 1. While x is less than 5, we'll print x. And then we'll set x equal to x, whatever it is now, plus 1. So we'll start at 1. 1 is less than 5, so we'll print 1. And then we'll add another 1 onto that. X will now become 2. We'll go back up. 2 is less than 5, so we'll print that, print 2. Then we'll add 1 more onto it. Go back up, and eventually we'll get to x equals 5. 5 is not less than 5, and so we will stop. So this will, what do you think this will print out in the end? It will print 1, it will print 2, 3, and 4, and then it will quit. Same exact thing, written out differently over here with a for loop. So we say for each, essentially the way to read this out is for each number, or sorry, for each num, or number in x, print the number. So for each item in this list, x, print the number. So it will also print 1, 2, 3, 4. Okay. This is very common when we have lists of data that we want to iterate through, that we want to go through. A little bit more detail here. You know, in Python, cases matter. So, you know, if I set lowercase x equal to Guelph, and then I try to print uppercase x, Python's going to get mad at me and say, I have no idea what you're talking about. Because cases matter. Okay, so that's a very common kind of error. Just pay attention to it. Make sure that you're getting your cases right. That's one reason why your program might not work. Some other methodology or terminology to keep in mind, especially as you become more advanced and begin to work with Python in ArcGIS. We have what are called functions. They're also known as methods. And these are, essentially prepackaged, oftentimes prepackaged kind of tools that Python makes available to us. They usually require what we call arguments. Okay? And I will share an example of that in just a second. Statements. So this is what we've already seen. So, we can declare something, in this case, x equal to Guelph. That is a statement. We are declaring x is equal to Guelph. Won't return anything, but we have stated it is the case. Modules. There are many different modules that we can that are kind of like behind the scenes in Python. So even though Python is getting behind the scenes of ArcGIS, there's even a behind the scenes or behind the curtains to Python. So that makes it easier for us to code. And when we put a bunch of modules together, we call it a package, which is what ArcPy, what we use in ArcGIS when we code Python in ArcGIS is called. It is a package. So let's look at this example right here on the right real quick. We import a module called math. So Python has a separate module where a lot of mathematical functions are stored. It's called math. And we just import that into our current session of Python using the import tool. And then we can use the math function, we can use the square root function or method to calculate square roots as just an example. So we would say math.square root. That is essentially telling Python access the square root function, the code that actually calculates square roots of stuff from the math module. Do that all for me. okay? And we would enter 100 as our argument if we wanted to calculate the square root of 100, and the result that would be returned to us would be 10. Now, I have offered a demo for some very basics related to Python, pretty much everything we've just gone over, but in practice, okay, and in particular geared towards helping you finish assignment lab number 5, where we are going to ask you to code a bit with Python, okay? So I recommend paying attention to this demo. It is a little bit long, but it will walk you through all of what you're going to need to be able to do for the 5th lab. I'm not going to walk through it right now, but it is available to you. I am going to just say a little bit more about what this all looks like in ArcMap, okay? And it looks a lot like something like this, okay? So let's see that, okay? At a very basic level, you can access Python through within various dialog boxes, okay? Just as in the field calculator, you can do Python and access Python. You know, when you're creating labels, you can actually use Python. If you get to the label expression menu, you can string together variables using the Python language. That's one way that Python makes itself visible to you within ArcGIS, and that's the code that you see there. But there are actually other ways that Python is available as well. Remember that every tool that we have in ArcMap, and in particular in the toolbox that we have in ArcMap, is essentially written in Python. Okay, we don't see the Python, but we can still. That's how it works, and we can access it. If you right-click and you can copy as Python snippet. Okay. ArcPy is the package of functions and modules that we will use to accomplish many different things using Python in ArcGIS, okay? So ArcPy includes helper functions that just, are kind of there to help you do the basics in your workflow, like finding the data and listing all the data you have, stuff like that. ArcPy also includes modules that extend Python functionality. So things like spatial analyst essentially pull up, allow you to access all the spatial analysis tools that module in ArcPy does. And then classes, which is a whole other beast that you may learn at some point, but I'm not going to get into much detail right now. This is what Python in ArcMap looks like. Okay, this is the Python window, console window, by which we can access and use and program Python within ArcGIS. Okay, so this is what it might look like. We might set a variable mxd equal to our current map document using the ArcPy package, the mapping module of that package, and the map document function. That all is just stringing together behind the scenes stuff that we don't really need to pay attention to. We just need to know the name of these functions and modules, okay? And what's really neat about this window is that it will kind of clue you into some things that you might want to do. Okay, so as you're typing it out, it'll offer you some suggestions of what you might want to do, like list all of your layers, or list all the data frames you have, or list the different layout elements you have, things like that. And so, this is embedded right in ArcMap. You have all the standard Python functionality that you saw in the demo available to you, but you also have access to ArcPy, that package of spatial analysis methods. So this can be a really great way to, if you had access to ArcGIS at the moment, experiment with Python and learn different syntax. And also to get some help. There's a really nifty help pane available to you with code samples that can help you complete, in this case, a buffer of your data. Okay, so just let's look at what's going on here. We've imported the package called ArcPy. We are accessing the buffer analysis function from it, and we were providing certain arguments to complete that function. So we're providing the input layer escolas, which is part of our map here. We want it to the output layer to be called the sort of basic, escola basic, and we want the buffer to be 3,000 meters, so on and so forth. And all these other arguments are just correspond to different parts of the buffer menu. Which we can learn a little bit about what those arguments are through the help menu. And even get some examples of what a successful buffer might look like written out in Python and ArcPy. This is not an easy process at all, okay? And, it's oftentimes we run into errors, okay? Now, just as much as learning how to program in Python is learning how to troubleshoot in Python and debugging, okay? So take a look at this error right here. This is an error that you might come across in trying to use Python in ArcGIS. How would you go about figuring out what's going on and solving the issue? So it does say a little bit about what the error is. There's no spatial analyst license currently available or enabled. How do you solve it? Well, remember we talked about how you have to enable certain extensions. Go to the Customize toolbar or menu, go to Extensions, and just click on Spatial Analyst. What about this one? This one's maybe a bit trickier. So I'm classifying a raster, and I run into this error. 999999. Error 999999. How would I go about addressing this? Even figuring out what's the problem, because in this case it just says error executing function, failed to execute. Well, great. That is not very helpful, ArcMap. Looking it up, ArcGIS tells me this is a generic error for which the cause doesn't have a specific ID. So it's just like there's an error. What do I do? And in fact, this is a known issue, or I should say that many errors in ArcMap are labeled 999999. It's just pretty much what ArcMap says when it doesn't know what it's doing and doesn't know what's going on. So, there's a lot of different debugging strategies that you can employ. And in particular for the next couple of weeks, the next few weeks, I want to outline a few. Definitely ask your TA, ask me, use the course link discussion board. We can work together to debug any issues in Python that we come across. Esri has, again, a great help menu, either within ArcMap, if you are using ArcMap for whatever reason, you won't be over the next few weeks, but in the future. Or the Esri has online help. For Python programming in general, Stack Overflow is going to be a great site. I guarantee you any error you have ever run into or any error you will run into, somebody before you has run into it as well, and they have posted their problem to Stack Overflow. Now, it might not be the same exact issue with the same exact data or whatever, but it is going to be the same general problem. And somebody has posted the answer, I guarantee it. So it's just a matter of you being able to use Google to tell the world what your problem is, and to find the answer, or a very similar answer, the general kind of answer you're looking for. Before you get there, though, you might double check your syntax first. That's a very common kind of problem. Maybe you've used the wrong case. Something was lowercase, but you use uppercase. Getting curly brackets and square brackets mixed can be, a big challenge, and cause some errors. So check that first. When it comes to ArcGIS and some debugging issues, workspaces are a challenge. I'm not going to go into that because we're not using Python right now in ArcGIS. You can search for the error number, right? When it tells you error 999999, you can search for that. If you add a little bit more detail about what you're trying to do, somebody might have had the same problem. Yes, so search for the function you were trying to execute. Just a little bit about syntax. I know that I said I would try to make Python as fun as possible, and I said it would automate your workflow. Many of you will find that actually it's not fun, and it's not automating anything. It's actually making things slow down a lot, and that can be because of a couple of big issues. So spaces, especially when you're copying and pasting code, you can add spaces where there shouldn't be spaces. Indentations, Python requires you to be pretty precise about how you indent the different lines of code. So pay attention to that. We're going to start wrapping up our discussion here of Python and automating workflows. But before we do that, I want to point out this what the ultimate value of using Python can be. And that is to escape ArcMap altogether. Okay, so we can actually use Python outside of ArcMap to complete all the things that we would normally do by opening ArcMap. So what do I mean by that? We can create what are called standalone scripts that we don't run in the Python window in ArcMap. We run outside of ArcMap in a separate tool, but that does all the same things. So we call these separate tools integrated development environments, or IDEs. So an example of that would be idle, which is the default IDE that is installed when you install ArcGIS. Spider is another one that you can download separately. And what these are they are kind of general purpose tools for you to program Python. They're really great because they kind of color code everything, as I've done in previous slides, so that you can know what are variables and what are strings and what are integers and stuff like that. And they also allow you to do much easier debugging. So it will tell you when something isn't indented properly and stuff like that. It will give you a much clearer indication of what's going wrong. And so you write out your entire script and then you run it. Unlike in the console menu where you have to go line by line, in this case you can write an entire script like this right here and then run it separately. Which allows you to do a lot more debugging because you can just revise your entire script as opposed to going line by line. And we can actually use these integrated development environments to do everything we would do in ArcMap. Okay, we have to import ArcPy, but once we do that, we have everything that's in the package ArcPy available to us. All those methods and functions, all those modules and their associated functions, which are just the spatial analysis tools that we have in ArcGIS. Okay, so in this case, we've imported ArcPy. We've used it to set our workspace, and then which just says, what folder we want to be working from by default. And then we use ArcPy, the buffer analysis function from this package to, put a 50-meter buffer around a roads layer. And we click run, and we don't need to have ArcMap open. We need to have it installed on our computer, but we don't need to have it open, because all we're doing here is we're telling the computer to use Python to pull up ArcPy and all the code in the ArcPy package, to pull up the buffer analysis function in particular from that package, to go to our road shape file, put a 50-meter buffer around it, and then output this data. And that can all be done outside of ArcMap. Again, because all ArcMap is anyway is Python code, so we can access that outside of ArcMap. Just, kind of cheat sheet for maybe when and where you should be programming, whether you should be doing it in the Python window within ArcMap or, outside of ArcMap. Really, if you want to do a lot more debugging, you should probably be using an integrated development environment. I've already mentioned some of the help that's available to you in ArcGIS or within ArcMap for getting Python. One really neat thing that I don't think I've mentioned is that whenever you run any kind of tool within ArcGIS, even if it's just a point and click, here's my buffer sort of thing, you can go to the results and right click and copy as Python snippet. So you will actually copy the Python code from whatever you just did. If you just ran a buffer the old-fashioned way, you can copy that as Python with everything already, pre-populated for you. So you could send that to somebody who wanted to see exactly what you were doing. You could send them the code that essentially you were running. It's just you caused it to run by clicking these buttons in ArcGIS. Same thing with Model Builder. You can actually export that all as Python script. And it allows you to then go in and modify a bit more your model. Some examples here of what like a more complicated Python workflow might look like for ArcGIS. I'm not going to go through these. These are here just for your just to kind of get a sense of what Python can accomplish. This is a very similar example to the one I mentioned earlier, where we're taking XYZ files that take hours to process and just kind of like, in this case, actually just rewriting the names of those files. This is essentially creating a bunch of different buffers around rasters. This extends on 2 slides here. Again, I'm not going to walk through this, but we're essentially doing some rasters. I have a couple of demos here for what Python looks like in ArcMap. I am not going to run these right now since we are not using ArcMap for the rest of this course. These resources are available for you if you would like to get a bit more hands-on sense of what Python within ArcMap looks like. And they will be available to you over the long term for future courses when you will be getting a chance to look at Python in ArcMap. But I'm not going to walk through them right now. And this first one is simply what the Python console window in ArcMap looks like. Spoiler alert, it looks something like this. And this is what it looks like. Well, later in this video, I would show you what a standalone approach outside of ArcMap would look like. And essentially what we're doing in these demos is using Python to automate a clip of land use data to several municipalities in Ontario, okay? So these are available to you. I'm not going to walk through them right now, but I highly encourage going through them. You will not be quizzed on them. They will not be, no content in these two demos will be associated with Lab 5 or, the take home. Certainly it will help improve your understanding of Python going through these demos, but nothing buried in them that's going to be quizzed or tested on. I've also got a little bit more here on how you can learn more GIS programming, okay? So we are trying to incorporate some introductions into this course. Didn't work out this year, but a few more courses that are online for the next few years that you can take that will give you more programming and GIS programming experience. There's also computer science courses that give you sort of an introduction to Python, especially 1500. Esri has introductions that are oriented around Python, sort of the basics, kind of what I've outlined and demoed. I considered offering them for the last few weeks of this course, but they actually require ArcGIS, so taking these trainings actually, they want you to have ArcGIS available to you, so just keep that in mind. And especially some of the more advanced ones here, they would also want you to have ArcGIS available to you. There are books for programming with Python, and ultimately, to gain even more superior skills, like there are diplomas that you can get in geomatics where you would be expected to do GIS programming. Okay. One thing I will point out really quickly is Lynda. So this is available to, this is actually called LinkedIn Learning. This has changed. It's called LinkedIn Learning now. And there are a vast number of tutorials available to you through that and through the university in particular, freely. So the university offers LinkedIn Learning access, which includes a bunch of Python tutorials that you can take that don't require super sophisticated software like ArcGIS. So this would just be sort of the basics to Python in general. I just want to say that going back to this diagram of like Python, the intimidating beast, it's all about what works best for you and for the task at hand, okay? So it is oftentimes maybe a better idea to use Model Builder to accomplish what you need to accomplish, and you shouldn't feel like upset or worried that you've got to kind of run back to Model Builder to do what you want. We have ways of iterating through our data in Model Builder, okay? Python might be more better at it and maybe more flexible in terms of iteration, but we can do it in Model Builder, all right? So keep that in mind. And of course, you are not going to get hands-on experience with Model Builder in this course at this point, but in future courses where you will get a chance to work with Model Builder as well as Python programming, just keep that in mind. So I've offered a couple of questions here that I will expect you to answer on CourseLink quiz, which you have until April 10th, the due date for Lab 5 to do. These questions will be the exact questions on the quiz, okay? So, pick your answer now. Okay, the first one here is, what will this model do? Okay, take a look at this model, work through the options, and tell me what you think this model will do. And the second one here is, what does this Python program do? What will it return after it runs, after I click run on this Python program? With that, we are out of time. I wish you all the best, and I will come back next week with a discussion of web mapping.